Hi guys, welcome to my channel. Today I will be solving one more problem from the Algo Expert site, and the problem name is longest mountain. So what the problem basically state that you will be given a array and you need to return the length of the longest mountain from this array. So what is the longest mountain? So longest mountain basically means then there will be exist one element, let's say index I, okay, and from 0 to I, the all the elements are strictly increasing order, and from I to some other index, let's say j, and this could be another index, let's say k, and from this I to j, all the elements are strictly decreasing order, and you need to return the length of the longest mountain array. This means from this index to this index, what is the length? You need to return it, and you need to return the length of the longest of that. So let's understand with an example. If you are given an array, let's say 2, 1, 4, 7, 3, 2, 5. So here you can see that from 1 to 7, all the elements are increasing order, and from 7 to 2, all the elements are steadily decreasing order, right? Like on this, and so like if I write it down like from array k, plus 1 still I, and from array I plus 1 is array of I still j. So here you can see the all the from 1 to 7 all the elements are in increasing order, and from 7 to 2 all the elements are decreasing order. So what is the length of this longest mountain here? Here length is 5, 1, 4, 7 and 3, 2. So what is the total length? Total length is 5, and there is no other index where you can get the value which is greater than 5. So here the answer is 5. Okay, now let's take another example. So if I say 2, 4, 3, 5, 7, 8, 9. So can I find out what is the longest mm, mountain in this array? So here you can see the from this is the one could be a one peak, and here if this is a peak of the mountain, then what is the length of the this mountain? Here you can see that 2 is 4 is greater than 2, and 4 is also greater than 3. So these three elements are considered as a one mountain, and here the length is 3. Now if I again move this way, like from 3 to 3, 5 is increasing, and 7, 8 still it is increasing order, from 8, 4 this is, and it is in decreasing order. So what is the length of here? So say 8 should be our peak element, and this side we are getting 3, and this side we are getting 2. So total 6. So here is the longest. Here is the length is the mountain is 6, and we are getting the, and there is no other subarray where we can found a mountain, and so our length of the longest mountain in this example is 6. So I hope you are now able to understand the problem. Now how we can solve this problem. So let's first understand what could be the brute force approach of this. So I'm writing down again here 3, 7, 8, 9. So basically what we are doing basically we are checking the if this element could be considered as a peak of the mountain or not. If it is the peak of the element, then we'll find some element from the left side which is from where all the elements are strictly decreasing order, and from 4 to other still other any other from other index we will also get some value which is also strictly decreasing order. So basically what we do, we will iterating, like we will consider every element, like from this index to this index we will consider every element as a peak element, and from this peak element we will found the length of the decreasing all the decreasing element from his left side. Let's say if the decreasing element count is count 1, let's say with some value 2, and from this peak element from the right side we are getting some we are calculating the how many decrement element we are getting from this peak element. If the what is the count is 2, yes, the count is 3, then what is the length of this length of this mountain? That is basically 2 plus 3 plus 1, because here basically we are doing comparison, not calculating the number of elements. So if there is a total 5 comparison, that's mean 5 plus 1 6 element. So what we are doing basically, we will consider every element as a peak element, and from this peak element we will find the left side how many elements are strictly decreasing, and from the right side how many strictly elements are strictly decreasing. So this way we will consider we will calculating, and basically and this approach will give me the solution, but it could be order of n square, because for every element we are considered as a peak element, and from this peak element we are basically traversing the whole array, if, like from left side and from right side also. So that's mean it is a order of n square solution. Okay, but this is not a very efficient solution. We need to reduce the time complexity. So how can we reduce the time complexity? Okay, now let's understand with how can we solve with less complexity. So basically what we are doing from the like from zeroth element, basically we'll start increasing how many elements are increasing order, and from and whenever we are not getting any increasing order, so that's mean this is the peak element. From this peak element we are basically again we are checking the how many elements are decreasing order. So basically like so what we like we are before that we are like considering every element as a peak element. So in that case we will not consider every element as a peak element, we will just iterating from this to like from 0th to still some element, and we'll check whether the all the element are strictly increasing or not. Okay, and if the all the element are strictly increasing one, then mean we'll calculate the how many element are like how many count are strictly increasing. That is basically we will compare every element with its next element, and how we'll calculating the what is the count value of this. Okay, so let's say if this is a we are checking the increment, or so if this is increment count, let's say with 2, and from this point we'll again go to some other point, we'll check how many element are strictly decreasing order. Okay, so we'll also check the what is the count of that. Okay, and while we are like after we are done with, like we are not getting any more decrement element, so that's mean this is one of the our mountain array, and we'll find the like we'll calculating the length of that. Okay, and we'll update this length, that is basically 2 plus 3 plus 1 in our we'll tag this with a max pointer, max value, and we'll update this max value. Okay, with this count, and once we are done with this, that's mean like this mountain array we are already covered, and then start iterating from this point, not before that any other point. Like before we are what we are doing in brute force approach, we are considering every element, like when we are like going to 2 4 3, this we could got one element, then we will not, we consider 4 as a our first peak element. Again we'll, what we'll do in brute force approach, we'll consider 3 as a first element. But we have already covered like 3 here, right? While we are checking this mountain array, we already come here. So then we will not consider this element, we will move to the next element. We'll, from there we also check how many elements are strictly increasing order or strictly decreasing order. So this way we will continue, and at the end of the day, like in end of this whole iteration, we'll find out the what is the length of the maximum mountain array. So what I'm trying to do basically, from here we'll start from here, okay, and checking how many element are. I'll just start down the same example here once again and iterating once again. Okay, now at first, or we'll start from here basically with j index, as the here it is says the length of the mountain is should be greater than 3. Okay, so from here we'll check is like, from here basically we'll check that array of, so this is j. Okay, we'll check that array of j is greater than array of j minus 1 or not. If it is greater than, then we'll, what is it, that's mean that this element is strictly increasing from its previous element. So that's mean we'll increase the increment counter. Okay, and this way we'll continue, like if it is come 6, okay, then again we'll increase the increment counter. So now increment will value is 2. Okay, and from here we are not getting any mm, further increment, so we'll check another while loop. Okay, and from there we'll calculating how many element are decrement element. So say 6 to 5 is a decrement element. In that case we'll check array j. So this condition we will check, and we'll check how many count are getting. So here from 6 to 5 we are getting one count. So we'll increment with increase this count with a decrement point, decrement value, like decrement variable. Okay, and we'll check that. And from 5 to 7 we are not getting anything. So we have reached here, and what is the increment value? Increment value 2 and decrement value is 1, right? So what is the length in that case? Length is 2 plus 1, which is, and plus 1, which is 4. So now we are this whole array we are getting 4 as a mountain array. Okay, and we reached here. Okay, and again we'll, yeah, we reached here. If we increase the j, like we'll increase the j value after this checking. So now j will come here. Okay, now again we'll do the same. So again these two will run again. So it will again checking the 5 is 7 is greater than 5, then 8 is greater than 7. So again we'll, this three element will count. That's mean again we'll increment count goes 2, and from 8 will again this while loop will run, and it will also do the same. So it will come here this three element, and decrement count also in that case will 2. So what is the length? Length is 2 plus 2 plus 1, which is 5. Now we are getting the maximum mountain length is 5, and which is greater than from our previous. So we'll update with this max value. Now we came here, right? Like after 3 will come here. So now j will pointer here. From j we are not like 8 is greater than 9 from, but here the increment counter value is 1, but decrement counter is not we are getting. So that's mean like whenever, like will this while loop, after like after from this to while loop, if the both increment and decrement value is greater than 0, that's mean we are getting some value. In that case we will only need to update the max value, otherwise we will not, because if we only get the increment value but not any decrement value, we will not will not update the max value. Okay, and sometimes it could be like 8 or 3. In that case, if it is the same element, then we need to just increase the increment, like will not do any while loop here, check anything this condition, like this condition basically breaks, and we'll just whenever the same element we'll just skip those elements basically. Okay, so this is the whole explanation. I will just write down the pseudocode here. Okay, so basically what we do, we'll check on pointer, that is basically j equal to 1, and also taking a max value. Okay, it's 0, and now we'll iterating while j less than, not length. Let's write down with 10, so that, so while j less than n, now what I'll do, we'll check, we'll take two pointer to count the increment value, it with 0, and decrement counter to check the how many element are decrement, so both will initialize 0. Then what we'll check, we'll take a while loop while j less than n, and we'll check array of j is greater than j minus 1. So this is basically we are checking the increment order, like from this we are taking some I, and so this is we are checking. So in that case we'll increase the increment counter and increase the j value as well, and we'll do the same for decrement as well while j less than n, and array of j is array of j minus 1. In that case we'll, this is the, like we are decreasing, like count the decrement, so we'll increase the decrement counter and also increase the j, and we'll, after this we'll check if the both value is greater than 1 or not, greater than equal to 1, that means greater than 0 or not. So if both the value of increment and decrement counter is greater than 0, then we'll update the max. Increment plus decrement plus 1. So this is the, if the increment length is some value and decrement length is also some value, that's been, from here we are getting count as a, like say 2, and here it is 3, so 2 plus 3, and this element also we need to consider. So this is, that's been 2 plus 3, and also increase, add 1 here. Okay, and then in the max we'll update this max, and if like after this we also need to check like if the element are equal or not, like if one example we have a 2 2 2, in that case we need to just keep it. Okay, so we'll do that same check here while j less than int, and check array of j equal to array of j minus 1, and we'll just increase the j plus plus. Okay, so, and basically what we are doing, we are taking the same j value and using in inside while loop as well. So this is a order of n solution. You might thinking like this should be also order of n square solution, because inside while loop we are taking another while loop basically, but we are using a, we are iterating using same variable, like same pointer. So that's mean like whenever this condition break, after this while loop breaks, like this while loop break, it will also check the same j condition and it also breaks, right? So this is order of n solution, not order of n square solution. So I hope you are able to understand the solution. I will upload my solution, and also problem link in the description. Please check it out. And if you do like my solution and my content, please subscribe my channel. Thank you.